Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about LCD interface. How the LCD will be interfaced with the 8051 microcontroller and what is the necessity and how that will be programmed. So these things we are going to discuss in this class. First, LCD display, it's a expansion is liquid crystal display. So this will be useful for displaying some outputs and then status of the results and other things in the embedded system. So whatever you are using some system, we are computing the results. So we need to inform that results to the users. So for that we need to use some output devices. So the LCD is the best device for displaying the informations, because whenever you are using 7 segment displays, it have only limited character displays. So if you want to display all possible characters, again different languages, everything possible by using this LCD character displays. So here it supports two mode of operations. One is 4-bit mode and another one is 8-bit mode. So 4-bit mode means it will be connected with a 4-bit microcontroller, or we can use it only 4 bits will be transferred at a time. And we can combine with this 8-bit, that is 8-bit mode. At a time 8-bit data can be transferred from a microcontroller to the LCD displays. So both two modes will be supported in a 8051 microcontroller. So here we are going to discuss about 2x16 line LCD display. That means it consists of 2 lines and each line it consists of 16 characters. So this is a standard size that will be used for displaying the informations, or we can have a higher displays like a 2x20 available, 4x20 will be available, 4x16 will be available. That means number of lines and number of characters in this each lines. So here we are using this 2x16 line. So 2 line and 16 characters per line. So first if you look at this output, look at this. So here this is a 2x16 we are displaying in first line, and second line we are displaying it a line LCD display. So here I can display up to 16 characters, and second line also I can display a 16 characters. If application requires more than that, I can go with a 2x20 displays. So this is the character formation of that particular displays. So here I am taking an example. A character will be displaying it. Look at this. So this is the formation of character A here. Look at this. So this is then actually 5x7 dot matrix display will be used. Look at this. So this is the B0, B1, B2, B3 up to B7, and this is D0, D1, D2, D4. So totally we have an 5x7 dot matrix will be available. Each one will be considered as one LED. So we can turn on or turn off an LEDs to form any particular character. So here I am taking a formation of character A. Look at this. For this I am turning on these lights. Look at this. So these lights will be turned on, and these lights also to be turned on, and these lights and these lights. It's form a capital A. Similarly, I can form a small a or any characters or any number or any special characters. Everything will be possible. Even if I need to display some Hindi characters or Tamil characters, that also possible. So normally for this we use ASCII codes. So whenever we send an ASCII code, the corresponding ASCII code will be formed to the lookup tables. So here look at this. So each displays whichever want that will be turned on, and remaining will be turned off. So it can form any particular character that we want to display for an particular users. So the preferred size available will be 5x7 dot matrix will be available, 5x8 dot matrix display will be available. So preferably maximum cases in application we use this 5x7. So this is the most convenient form that will be used for displaying that informations. So any character. So whenever we need some Tamil characters, so we need to write the Tamil characters, and then depending upon that we can form a lines. So what are the LEDs to be turned on? We need to make it as a 1, and what are the LEDs to be turned off? We make it as a 0. So for each row we get one value, and all the values will be combined, and that will be formed as a lookup table, and that will be stored in RAM, and that will be used for displaying that informations. So here I am showing that how that signals will be connected to the LCD. So here if you are taking this 16 cross 2 lines, so it have an 8 data lines, that is a data line D0 to D7. So total data lines will be 8. So look at this. So this is D0, D1, D2 up to D7. These 8 lines will be on data pins. So whenever you are using an 8-bit mode, all 8 bits will be connected. Whenever you are using a 4-bit mode, only 4 lines will be connected, and remaining 4 will be unused. And look at this. So we have a 3 control lines. Look at this: RS, RW and E. So these are the 3 control lines. This will be used for an controlling that LCD. So the purpose is RS is a register select. Whenever you are sending some data, the data may be a control value or there may be a data. So for example, if you need to initialize LCD, so for that we have some initialize values. So if you are sending that, that will be controlled as a control values. So whenever you are sending some data, for example, I want to display character A, so that will be data value. Whenever you are sending a data value, that register select should be selected as a data lines. So whether we are sending a value, control value or a data value, that will be selected by this RS value. If RS is 0 or 1, depending upon that, register will be selected. Second one will be RW. This is read write logic. So normally we use only LCD display to display that information. So for that we need to only write the information. Sometimes we want to read the statuses, we can use the read mode option. So there is a 2 possibilities. One is by using delay we can write the data. Sometimes we use this, whether LCD is ready or not, we check it. After that we write. For that we need to use this read option. And then third pin is EN. EN will be used for enable pins. So whenever we are sending in high to low pulse to enable pins, the data present in data lines will be latched to the LCD displays. So the remaining 5 pins that will be used for a power supply and backlights. Look at this. So this is VSS, this is for a ground, and this is VCC, this is for plus 5 voltage, and this is VEE, this is contrast control. Contrast control means we can increase or decrease the contrast for an easy displaying that information. Look at this, this is the actual LED backlight, so the LED plus and LED minus, that is LED anode and cathode. This is for the background LED on and off. Look at this, this is the circuit diagram of 16x to LCD displays. So we need to connect this data lines D0 to D7 to the port 1 and control lines RS, RWE. So RS will be connected to port 2 0th pin and RW will be connected to port 2 1 pin and E will be connected to port 2 2nd pin. Look at this. So port 1 0 pin to 7 pin. So all 8 pins that will be connected to the pin number D0 to D7. So this is actual data bus will be connected to LCD. And look at these control signals. So look at this P2.0. So P2.0 will be RS that will be connected to this RS pin. And then P2.1. So this is the read write signal, whether read operation or write operation. This will be connected here P2.1. And P2.2 this will be used for an enable pins. I am connecting to this. So this is the data lines and this is the control lines. Look at this power supply. So 5 voltage will be connected to VCC and ground potential will be connected to this ground. And for VEE, this is a contrast control. I am using this for 10K potentiometer and connecting to that pin. So what happens? I am adjusting this for 10K potentiometer. I can increase or decrease the contrast levels. So we need to connect this D0 to D7 data pins to 8-bit. And then RS, that is the register select. So 0 for a command word and 1 for a data word. So whenever you are sending a commands, we need to set this line as a 0 for commanding. And whenever you are sending a data, we need to make this line as a 1. And read write logic. So this pin, if you connect to 0, it performs this write operation. If you connect to 1, it performs a read operation. So normally we perform only write operations. Whenever you are checking the LCD status, we can use this read operation. And this enable, so this is the latching pin. We need to give a high to low pulse to this enable pin to latch the program. Thank you.